Good morning, students. We'll continue our topic from chapter Organic Chemistry. Students, we have done the nomenclature part, and this is now the second part of the chapter. Only the one nomenclature is being left, that is of aromatic compounds, which we will take along with the one more concept, that is resonance. Then I'll take that concept along with it, right? So today we are going to start our second part of this chapter, that is isomerism, students. What do you mean by isomerism, students? Isomerism, to understand the isomerisms, you must know about the isomers first. And you know your isomers, that if two or more compounds having the same molecular formula but differ with the physical and the chemical properties, they are known to be isomers, and the properties are known as isomerism. You know very well, in class 10th you have done about the isomers, students. So as such compounds which have two or more compounds but they have same molecular formula but differ with the chemical or physical properties, right? So basis on that, we have two types of isomerism: structural isomerism and stereoisomerism, students. Stereoisomerism is not in our syllabus, but I'll tell you a little bit about it. But structural isomerism we have in syllabus, and structural isomerism has been classified into four main types. One is a chain isomerism, position isomerism, functional group isomerism, and metamerism, right? So I'll discuss the chain isomerism first. Chain isomerism, when two or more compounds have similar molecular formula but differ with respect to the carbon skeleton. It means if I talk about pentane chain, we can be rewrite this pentane chain in different forms, right? In the form of a branch chain, more branch chain. So these two isomers only differ with respect to the carbon skeleton, how we have represented the carbon atoms. Either we can write in a straight chain or in a branch chain. So these two isomers have same formula, that is of C5H12, these three of them, but they only differ with respect to the carbon skeleton, because one chain is straight chain and the second one is a branch and the third is highly branched. Only this is a difference in the chain isomerism. As you can see the example of pentane, the formula of pentane is C5H12, students, and pentane can be rewrite like that. One of the methyl can be shifted to the another carbon, and the next formula is isopentane or 2-methyl butane. No need to done the common naming of that, only just do the IUPAC naming. And again, one of the CH3 can be shifted to the another carbon to form a new isomers, and it will be 2,2-dimethyl propane, as people know, and you have already done that. Second is a position isomerism, students. When two or more compounds differ in the position of substituent, either they differ with respect to the substituent attached or a functional group, right, in this carbon skeleton chain, and they are known as a position isomers. How the people are differ only with respect to the position of functional group or the position of substituent. As you can see the example C3H8O, this is an example of an alcohol, and propane 1-ol and propane 2-ol, both are position isomers, because here the formula is same, but both of them differ only with the position of the functional group being attached in the carbon atom. The third one is a functional group isomerism. As such, the name suggests, two or more compounds having the same molecular formula but differ with respect to the functional groups. They are known as functional isomers, and isomerism is known to be functional group isomerism. This is one example. C3H6O can be rewrite like propanone and propanol, although both the groups are different. Right, students? Here, one mistake is there in the formula of propanol. I think it's just a typing mistake. This H is along with this carbon atom, not this, because valency of the center carbon atom is already completed. So this H is being linked to this C, not this, students, right? So you can correct it. It's by mistake. It's a typing mistake only. Now next is a metamerism. This is different, students, because the last three which we have done, the previous one which we have done, already we have done in the 10th class. But this is a new concept that is called metamerism. So metamerisms are those isomerisms, those structural isomerisms, which have same molecular formula but differ with respect to the different alkyl chains on the either side of the functional group, right? Suppose we have one functional group ether, students, and here we have one CH3 on this side, left hand side, and on right hand side we have three carbon atoms. Here one and here three, right? And the same we can write two carbon atoms here, two carbon atoms are here, and along the either chain of the either side of the functional group you can see, right? Both have same formula, it means both have four carbon atoms, right? And both have 7 and 3, 10 hydrogen and 1 oxygen. Here also we have 10 hydrogen, 4 carbon and 1 oxygen, but they can be rewrite like this. So these both are metamerism, and metamerism arises due to the different alkyl chain on the either side of the functional group. Suppose we have a functional group on both the sides, the arrangement of carbon atom is, or alkyl group is different. That is called metamerism. Now, this topic is not included this time in this syllabus, that is stereoisomerism, students. We will do that stereoisomerism in class +2. So we don't have this topic too much about that in NCERT. Just you should know about the idea, what is structural isomerism and what is stereoisomerism. So structural isomerism में हम करते हैं जो differ करता है with respect to the structure of that molecule, right? Same molecular formula but differ with respect to structure. But in the case of stereoisomerism, what is the stereoisomerism, students? The compounds that have the same constitution and sequence of a covalent bond but differ in the relative position of their atoms or groups in space. Only the one word is being added, that is called space. Otherwise, the whole definition is same as that of structural isomerism. And this is a special type of isomerism, and it can be classified as geometrical optical isomerism, which we will do in a class +2. Next part is fundamental concept in the organic reaction mechanism, students. So now we're dealing with the organic chemistry. You should know what are substrate, what are products, what are attacking reagents, right? So the substance we're talking about, which we talk about, that is organic molecule, is known to be a substrate. When the attacking reagent attack on it changes into product, but there is one intermediate or a byproduct, we can say, between a substrate and a product, or reactant or a product. reactant and product के बीच की जो स्पीशी होती है उसे हम बोलते हैं इंटरमीडिएट, और वो कैसे बनती है, जब रिएक्टेंट के ऊपर कोई अटैक करता है, एंड दैट अटैकिंग reagent, that is known as attacking reagent. We'll talk about the intermediates later on, but because this is in your syllabus, we have basically 5 types of intermediate. Out of 3 is in syllabus, that is carbocation, carbanion and free radicals. Rest, the 2 carbenes and nitrines are not in syllabus, right? So we'll discuss that in my next video. This time we should know about the journal terms. In an organic reaction, the organic molecule, also referred as substrate, when reacts with an appropriate attacking reagent and leads to the formation of one or more intermediates and finally the product. This is just a flow chart showing you how reactants react to form the products. And between that, a byproduct is being formed, a short-lived species being formed, which is known as intermediate, and how it is being formed when a reagent attack on the substrate molecule. So substrate is that reactant which supplies the carbon to the new bond, and the other reactant is known as reagent. And if both the reactants supply carbon to the new bond, then the choice is arbitrary, and in that case, the molecule on which the attention is focused is known as substrate. This arbitrary and this case on which the molecule on which the attention is being focused is called substrate, students. Please remember this. Reaction mechanism. What is reaction mechanism, students? A sequential account of each step describing the detail of electronic movement. Energetic means energy change during the bond formation or bond dissociation, and the rates of transformation of reactants into product, it means the speed of the reaction. Reaction mechanism means how the reaction is being carried out in every steps. what is the electronic movement, how much energy is being gained or lose, or what is the bond cleavage, is the bond formed or not. So this topic is something different. We'll talk about the bond cleavage here. What do you mean by bond cleavage? We'll deal with that. So we have two types of covalent bond, students, and how we can break them. That is called fission of covalent bond. So cleavage can be done in two ways. We have two type of cleavage because we have two type of bond. One is a homolytic and another is a heterolytic, students, right? If two species are there, suppose A and B, and have of equal electronegativity. Electronegativity here means tendency to attract the shared pair of electron. It means if two persons are there and having the same qualification and same qualities or skills, then the equal division is being occurred. In that such pair is known as homolytic fission, जिसमें दो सेम पर्सन के पास दो सेम स्किल्स हैं हमारे पास और दोनों ही सेम इलेक्ट्रोनेगेटिविटी के हैं, तो इसका मतलब है दोनों में बराबर बराबर डिस्ट्रीब्यूशन होगी, इक्वल डिस्ट्रीब्यूशन इज देयर, दैट इज कॉल्ड होमोलिटिक क्लीवेज. एंड व्हाट डू यू मीन बाय हेटेरोलिटिक क्लीवेज? In which one of the atom or one of the that compound is more electronegative than the other. So which is more electronegative, it will attract all the electron pairs and the another will become the electron deficient. So try to understand. First of all, I'll tell you about the homolytic, students. In homolytic cleavage, one of the electron of the shared pair in the covalent bond goes to each of the bonded atom. It means an equal division is there in the case of homolytic fission. Homolytic fission is as such that equal division is being occurred between the two atoms, students, right? So there is a formation of free radicals. When the covalent bond undergo the cleavage, the homolytic cleavage or homolytic fission, in such a way that the atoms joined by it get one electron each, and these species are known as free radicals. And the second is a heterolytic, students. In heterolytic fission, the covalent bond undergo cleavage in such a way that both the electrons are being taken by only one of the atom, which is more electronegative in nature, and the rest got the positive charge, right? It get the positive charge, students. Like out of A and B, suppose A is more electronegative, so both the electrons will, one of the pair or electrons will go to the that carbon atom and another will be electron deficient in nature, right? Or we can say that out of A and B, if B is more electronegative, then B will attract all the pairs and the A will get the positive charge on it. So depending upon electronegativity difference, there are two type of cleavage: covalent bond cleavage or fission. One is heterolytic and second is homolytic. I have shown you like CH3Br. So out of this carbon and bromine, bromine is more electronegative in nature. It will take away all the electrons and CH3 will acquire the positive charge. Clear, students? Based upon that, we have different type of intermediates, which I'll deal with them later. See, this is homolytic, and if homolytic cleavage occurs when heat or light falls on it, suppose R and Rx is a species, R and X will equally be distributed, electrons will be equally distributed among them. They are known to be free radicals. And in heterolytic cleavage, there will be the formation of cation and anion. Now, they are known as attacking reagent, students, right? So there are two terms which are very, very, very important, that are nucleophile and electrophiles. So what are attacking reagents, students? Those species which attack the given organic molecule. I told you about the attacking species in my previous flow chart. So we have basically two types of attacking species, nucleophile and electrophile. Nucleophile is being represented by Nu and electrophile is E positive. So nucleophile means a reagent that bring an electron pair, or that is nucleus seeking, and the reaction is known as nucleophile. It means nucleophile is what? Nucleus loving, right? Nucleus loving, or we can say nucleus attracting, right? Because nucleo means nucleus and phile means loving. So nucleophile is that attacking reagent which love or have an attraction for the nucleus or a positive part, right? So it is therefore either negatively charged or neutral, but with at least one lone pair. There are two types of nucleophile basically. One is negatively charged nucleophiles because they are rich in electrons, so they can be classified into negative charge or neutral. Neutral means having lone pair, students. So negatively charged nucleophiles are H negative, Cl negative, Br negative, I negative, OH negative. They are known to be negatively charged nucleophiles. And the examples of neutral nucleophiles are like H2O, because oxygen have lone pair on that, alcohol, amines, right? Ammonia, because nitrogen has lone pair on it. Now, what are electrophiles? Electrophiles are the electron seekers. It means they are electron loving, and they are the attacking reagent will love or have an attraction for electron students because they are deficient in nature. That's why they are always electron seekers, right? So there are, based upon that, we have two types of electrophiles: positively charged. All the positively charged that species or electron deficient species are known to be electrophiles, such as H positive, Cl positive, plutonium ions, NO positive, NO2 positive, and the neutral, who are having who are electron deficient, whose central atom is electron deficient according to Lewis concept. BF3, AlCl3, FeCl3, these all are electrophiles because their central atom has incomplete octet, right? So I hope you have understood. We'll discuss more about it in my next video. Thank you very much.